Kia ora. In Year 12. This is another harder trig equation problem from the worksheet that's up on the Wellington College website. In this one I'm deliberately going to show you what happens if you don't see what to do straight away. So we're going to go on a bit of a wild goose chase to start with. So when you look at this equation, you can see that you might be able to somehow turn it into a quadratic. But one thing that's a bit irritating is that I've got a 2 theta here and just a theta here. So you might think that a good thing to do would be to take your sine of 2 theta and apply your double angle rules. So we're going to start by doing this, and we're going to see that it's not really going to help. Well, I gave up doing it this way pretty quickly. You might keep going. So we get 2 sine theta cos theta, and now we've got plus 4 sine squared theta equals 4. So let's just work with that, and we get 10 sine theta cos squared theta plus 4 sine squared theta equals 4. Now I can divide through by 2, but I'm actually not going to bother doing that just yet, so I'll just leave it how it is. Now I'm looking at the cos and I'm thinking maybe I can get a quadratic in sine if I do my Pythagoras substitution. So you can look at the first of the harder trig equation videos to go over that. Basically what I'm going to do is when I see the cos squared, I'm going to replace it by 1 minus sine squared theta plus 4 sine squared theta equals 4. Right, so we expand that out. We've got 10 sine theta minus 10 sine cubed theta plus 4 sine squared theta minus 4 equals 0. So I've got a cubic, which is not really what I want. I could try factorising that cubic, but the thing that we're best at is solving quadratics. So at this point I'm going to give up and I'm going to say, what was the other thing I could have tried back in my original equation? And that's to substitute using Pythagoras for the sine squared of theta. So I'm going to do that on the next slide. Alright, so we'll start again. So I guess what I'm trying to show you is that it's not that unusual with these pretty tricky trig equations to go down a dead end. And if that happens, you just have to get on with trying. And the more equation practice you do, the less often that will happen. But it still does. So this time I'm going to leave the sine 2 theta where it is. And I'm going to replace the sine squared theta like that. Now straight away you'll see that something different's starting to happen. I've got a plus 4 over here and a plus 4 over here. So that's good because those are going to vanish like this when I subtract them from both sides. But not quite yet. So here we get plus 4 minus 4 cos squared theta equals 4. So I can subtract these from each side, leaving me with 5 cos theta sine 2 theta minus 4 cos squared theta equals 0. And suddenly I've got a really quite a straightforward factorisation problem. I've got a common factor here of cos theta. So we'll take that out and we get cos theta times 5 sine 2 theta minus 4 cos theta equals 0. So this equation is going to be true when cos theta equals 0 or when 5 sine 2 theta minus 4 cos theta equals 0. Now it's not completely straightforward because I still have to do some work on that one, but I can solve this one. So I'm going to leave that until we've manipulated this one here a bit more. Okay, and then we'll solve both of the easy equations at the end. Okay, so what am I going to do to solve 5 sine 2 theta minus 4 cos theta equals 0? Well, the only obvious thing to do is to do my substitution in here. So 5 times 2 sine theta cos theta So double angle formula for sine, which you should know by now. Remember, you do get that in the formula sheet, but you'll be a bit too busy to be looking at it. So I've got 10 sine theta cos theta minus 4 cos theta equals 0. I'm going to do. Okay, so now the last few steps here, I'm going to divide through by 2 and take out a common factor. So I've got cos theta times 5 sine theta minus 2 equals 0. So this will be true when cos theta equals 0, or 5 sine theta minus 2 equals 0. Now this, of course, is the equation we got for the first part. So now I've got 3 equations, but really 2 to look at. Well, I've got the first cos theta equals 0, and now I've got it again. So I'm going to have to work with that one once and this one. So let's first solve cos theta equals 0. Well, alpha is equal to the angle whose cosine is 0, which is pi on 2. So here I'm looking at getting the general solutions for these two equations. So we get theta equals 2n pi, right, the general solution pattern for the cosine equation, plus or minus pi on 2. So that's my first solution. There we go. Second solution, nice easy one again. So sine of theta equals 2/5 or 0.4. So alpha is sine inverse of 0.4. That gives me 0.4115 to 4 dp, leaving me with theta is equal to n pi plus my switching function, -1 to the power of n, times 0.4115. Okay, so that's all. So you can see, once you see the right substitution to do, the quadratic falls out of it quite quickly, and then all you've got to do is break it down into factors and do your general solutions on each one. Thanks for watching.